In the last video, we talked about HDMI and its different versions and the speeds. So in this video, we'll go over the Ethernet cable, the cable we all use to connect our computers, routers, and servers to the outside world. You might see other cables used alongside Ethernet, like coaxial cable or fiber optic cables, but in this video, we're focusing mainly on the Ethernet cable. Ethernet cables come in different versions and speeds, just like any other type of cable. They're made up of twisted wires that come in different colors. That's why Ethernet cables are also commonly known as twisted pair cables. The reason they are twisted is to protect the signals from EMI, electromagnetic interference, and ensure data is transferred properly and efficiently without disruption. The wires are color-coded in blue and light blue, green and light green, brown and light brown, and orange and light orange. So how do they protect these cables from EMI? Ethernet cables are either shielded or unshielded. Shielded means the cables and or the wires are wrapped with some type of shielding such as braid or foil, and sometimes the shield is only around interior cable, and sometimes it's around both the interior cable and the individual wire pairs. Unshielded is the opposite. There's no shielding around the cable or the wires. How do you know which type of cable you're holding? There are markings printed on the cable. For example, STP means shielded twisted pair, UTP means unshielded twisted pair. As you can see, the wires are placed into specific pins in the header. Now the question is, do they still work if we put them in different pins? The answer is yes. We use two Ethernet wiring standards, T568A and T568B. You can choose either one, and they will work just fine as long as you use the same standard throughout the network. You can't mix both on the same network connection because that will not work. Let's get into the different types of Ethernet cables and their speed. Have you ever heard of IEEE 802.3? They're the committee responsible for defining Ethernet standards. When someone says, I have a Cat5 cable or buy a Cat6 cable for your network, those Cat numbers come from the IEEE 802.3 standards. It's actually category, so they abbreviated it into Cat. The first widely used Ethernet cable was 10BASE-T, which used Cat3 cable. It supported 10 megabit per second of speed with a maximum length of 100 meters. Definitely not something we can rely on today. Next came 100BASE-TX, which still had a maximum length of 100 meters, but increased the speed to 100 megabit per second and used Cat5 cable. Both of these earlier cables used only 2 pairs of copper wires, which is 4 wires total, even though the connector had 8 pins. In fewer cables, all four pins or 8 wires are used. Then we moved on to 1000BASE-T, which supported 1 gigabit per second of network speed with the same 100 meter length. A new version of Cat5 was introduced called Cat5e, which used all 4 wire pairs. From this point forward, Ethernet cables stopped using 2-pair wiring because it couldn't support gigabit speed. After that, we got 10Gbps-T, supporting 10 gigabit per second. This type came in 2 versions, unshielded and shielded. The unshielded version had a cable length of up to 55 meters, and the shielded version had a cable length of up to 100 meters. And if you're wishing the unshielded version also worked at 100 meters, don't worry. Cat6A came right after, and it supports 100 meters whether shielded or unshielded. Next up is 40Gbps-T, which has 40 gigabit per second of speed and uses Cat8 Ethernet cable. But can it reach 100 meters? No. Its maximum length is 33 meters. Now let me ask you this. Do you think Ethernet only comes in copper cables? No. It comes in fiber optic form as well. Before I talk about the names, let me explain the differences between copper and fiber Ethernet. Fiber can break the 100 meter limit and reach up to 10 kilometers or even 100 kilometers without losing data quality. Copper uses electrical pulses to transfer data, while fiber uses light, either laser or LED. which makes it extremely fast. We'll go over fiber in more details in a separate video. The first fiber Ethernet standard was 100 base FX, which supported 100 megabit per second over fiber. Depending on the type of fiber cable, it could reach anywhere from 400 meters up to 2 kilometers. Next is 100 base SX, which is less expensive than the FX one, and it can go up to 300 meters. If you really want to use fiber but don't need long distances, this one is a good option. And then we have 1000 base SX supporting 1 gigabit per second with a distance of 220 meters up to 550 meters. Again, depending on the cable type. If you want longer gigabit performance, you can use 1000 base LX, which supports distances from 550 meters up to 5 kilometers. And last but not least, we have 10G base SR and 10G base LR. SR supports cable length from 20 meters up to 400 meters. LR, on the other hand, can reach up to 10 kilometers. That's all for today. We went over Ethernet cables and the different types available. If you found the video helpful, don't forget to share it with friends and family so they can benefit from it as well. See you in the next one.